everyone. Today's experiment is the melting point determination, and as you will see in your report manual, as you should know, the melting point is very important characteristics of any organic compound. The determination of the melting point, actually we use it for two purposes. First, to determine the purity of the compound, as we will see and we will explain during the experiment. And second uses of the melting point is simply to determine the identity of the compound. If we have certain list of possible compounds, then whenever the melting point matches a melting point of certain known compound, most likely then the compound is the same, but not always true. Anyway, now what's the melting point? Melting point, as you know, it's a temperature at which we do have an equilibrium between the liquid state and the solid states. In other words, it's simply the temperature at which the compound converted from liquid to a solid. In principle, actually, we as organic chemists, we always interested into two things. The range, actually, of the melting point. The range of the melting point, we do have the lower end and the higher end. The lower end is always the temperature at which the compound starts to melt, and the higher end is the temperature at which the compound fully converted from solid into liquid. So this range is extremely important for us as organic chemists, because as I said before, this will tell us or will give us an idea about the purity of the compound, if the compound is pure or not pure. So regarding the procedure, what we need actually to determine the melting point, we need melting point apparatus. As you can see, it's just electrical heater which simply can raise the temperature slowly, and we can control the temperature raise. Now, what you will see here, we have two knobs here. We have a knob called rapid heat, and we have what's called hold display. And we have simply this knob which starts to increase the temperature. As you can see here, we can increase the rate of the temperature like 2 degrees per minute, 3 degrees per minute, 4 degrees per minute. It's actually based on whatever we want. Based on this knob, actually it determines a rapid heat. Actually, the heating of the substance will increase rapidly, and especially this is actually not to waste a lot of time, especially for the first measurements, because generally speaking, we don't determine or record the melting point of the compound only once. We do it twice or 3 times in order to be sure about the range of the melting point. So let's just move stepwise, actually based on your procedure. First of all, we need to take a small sample of the compound which you would like to determine its melting point. And first of all, you have to determine the melting point of two compounds: pure benzoic acid, which I hold it in my right hand, and impure benzoic acid, which I'm holding it in my left hand. And we want to see by ourselves how the range of the melting point will be affected by purity. So let's start with, let's say, based on let's start with the pure benzoic acid. So we take small amount of the compound which you would like to determine its melting point, very small amount in order not to waste a lot of compound in here, and we place it on a watch glass, if you can bring it closer, and then we need to crush the crystals to make them as powder as possible in order to have more accurate melting point determination. As you can see, I use the spatula in order to crush the crystals and to convert them into powder. And then we use a capillary tube which has two ends. It has closed end and open end. And of course, we take the open end and we flip it over. We just make it upside down in order to try now to press it into the powder, and then we tap it a little bit in order to bring the powder downward to the closed end, as you can see here. You see, we do not add much of the compound, and the height of the powder inside the capillary tube should not be more than 1 to 2 millimeter actually high, in order again to have as accurate and precise reading or recording as possible. After that, we just place this capillary inside inside this apparatus, which has 3 holes. You can insert it anywhere, and then we turn on the heater. Now the heater, generally speaking, in order not to wait long time until we reach the melting point, first we raise the temperature rapidly until we get the 80 degrees. If you notice now, when this knob is on, you will see the rate of heating is very fast, and this is actually, again, in order not to waste a lot of time waiting for the compound to get melted. If you just focus on the thermometer, the temperature here, you can see here, the temperature here is raising so fast because simply we have chosen the rapid heat. Now, of course, you are now determining the melting point of known compound, which is the benzoic acid, which we know its melting point, and the melting point is in the range of 120. So to raise the temperature very fast, rapidly to the 80, it will not affect our measurement. We will definitely get an accurate measurement. So we let the temperature increase rapidly, as I said, until it gets to the 80. Then we turn the rapid heat off, and then we allow, in this case, we will allow the temperature to increase, but slowly, until the whole compound will melt. In this case, in here, we will always focus or keep our vision into this mirror, this lens here, in order to see what's going on. I don't know if you can see it, and if you can bring it closer. Can you see through the lens? You see it? Can you see the solid inside the lens?
Because of the light, it is not possible.
All right. Anyway, what you have to do, actually, you have to keep looking and watching what's happening. You can see now the temperature is 80. Then I turn the rapid heat off, and now what you have to notice, what you will see now, is the temperature will increase, but it will increase slowly. So the acceleration of the rate increase or the temperature increase will be slow enough in order to allow you to determine the temperature. Because if the heating was so rapid, then the compound will take the energy, it will melt, but without really for you to be able to record the accurate melting point. In this case, after the compound melted, then we record the lower range of the melting point and the higher range of the melting point. You will see, or you will find the report as it's supposed to be downloaded in the Moodle. For example, in this case, I determine or I record the melting point. For example, once it has been melted, I just have to wait and see. We can take a break until it melts fully, and then we can record further more. Just stop it. All right. As you can see here, we have the compound, the solid, has been converted fully to the liquid state. And as you can see, I have used the whole display in here because I recorded that the initial melting point when the compound starts to melt, it was 121.7 now, and then I finished the experiment, or I stopped the recording when the solid fully converted into liquid phase. In this case, in order not to lose this screen, I use the whole display, in which here it will simply hold the display when you press that knob. In this case, I have recorded the melting point of the pure benzoic acid 121.7 to 123.4. In this case here, I have my melting point determination of the pure benzoic acid. As you can see here, as you will see in your report in the model, now the range of the melting point is very narrow, is very sharp, which means it does not exceed 1 to 2 degrees centigrade. In this case, whenever you have a melting range of a compound not exceeding 2 degrees centigrade, then we should expect that this compound is pure compound. If the range is bigger, then definitely the compound is impure. And that's actually what you're supposed to do when you determine the melting point of the impure benzoic compound, exactly following similar steps what you have done and what you have followed for the pure benzoic acid. After that, actually your practice or your training, what you're supposed to, or you was supposed to take one of these unknowns and simply record the number. For example, here MP33, I supposed to record this unknown compound in my sheet, and then I supposed to determine the melting point of this compound. Then after I determine the melting point of this compound, and suppose I found it to be, for example, 100, let's say, the unknown measurement or the unknown compound, as I said, MP33 or 43, for example, MP43. I found the approximate melting point of this compound was, let's say, 142 to 146. Then when I repeat it, then I found it to be 144 to 147. That means when I compare now the melting point of the unknown to this known compound, I will find that this is the closest melting range to this compound, which is 2-amino-benzoic acid. So I should conclude that my compound is, or my unknown compound is 2-amino-benzoic acid. With that, actually, we are done with the experiment, and that's all for the melting point. Inshallah, next week we will have the second experiment, which is the recrystallization. Thank you for attendance.